Sex-linked patterns of inheritance. So, what are sex-linked patterns of inheritance? Well, sex-linked inheritance may occur when an allele causes effect on a sex chromosome, either the X or the Y. And women can either be carriers, infected by it, or healthy, while men can only be infected or healthy, and they can't be carriers. Why, you may ask? Well, men cannot be carriers as they only have one X chromosome, while females have a second X as a backup. Men instead have a Y. This is shown on the photo on the right. You look at the red, which represents the man, and the blue, which is the woman. So the red, it shows on the left of it an XY. That means it's a man because they have an X and a Y chromosome. The female, the blue one, has an XX, meaning she's a female. This photo is by RamneetCoward.com. So today we'll be solving a sex-linked inheritance practice problem. So it says, 2 normal vision parents produce a colorblind son. Draw a pedigree that includes every person, 3 people mentioned in the story. Include a Punnett square of the parents. So let's start by going down to the genotypes of the parents. Mom can either be XR, X capital R, X lowercase r, or X lowercase r, X lowercase r. And dad can either be X capital RY or X lowercase ry. So let's just start with the dad over here. He cannot be X lowercase ry because that would mean he had color blindness and it said both parents are normal. Same with the mom with X lowercase r, X lowercase r. So we know both options are eliminated. Now if we look over at the mom, since we have 2 options left, to produce a colorblind son, she needs to carry at least one of the traits, so it cannot be X capital R, X capital R. So she's heterozygous and a carrier. This helps us to be able to draw the pedigree. Start with the dad. He's a square because squares represent males, and he's married to his wife. And since his wife is a carrier, we'll shade her in half. They both had a son who's colorblind. So we color him in all the way, right like that. Now that we have that done, let's make the Punnett square. So let's begin to draw it in. Here's our square. So the mother is X capital R, X lowercase r, and the father is X capital R, Y. So their son is either X capital R, X capital R, X capital R, X lowercase r, X capital R, Y, or X lowercase r, Y. And we know he has to be this last one because he's colorblind and he's a male. So let's now go down to this next part. What are the chances of the next child being a colorblind daughter? Well, if you go back to this Punnett square, you'll notice it's impossible because there's no options that show X lowercase r, X lowercase r. So it would be 0%. Before having this first child, what was the probability this couple would have 3 children, all healthy? So if we took this Punnett square and did it 3 times, the children would be healthy 3 out of 4 times. This is because, although they're a carrier, they'd still be healthy. So we do 3 times over 4, times 3 over 4, times 3 over 4, which would equal 27 over 64. So they would have a 27 over 64% chance that their children would be healthy. Or, if you wanted to simplify it, 42%, although it just asks for probability, so that does not really matter. And finally, we're on to our works cited, including Beverly Biology, Biology Roots for the practice problems, and for the photos, osmosis.org, drlib.info, Khan Academy, RamneetCoward.com, Socratic.org, and XP.com. Thank you so much. Bye.